Students, topic for today is 8253. 8253 and 54. 8253 and 54 are basically nothing but a programmable interval timer. Programmable interval timer, as the name suggests, it is a timer. Timer, and it can work like a counter. What is a timer? Timer is something which provide a time delay, and counter is a something which gives us some event after a specific count. Okay, if we set a count like let's say 10, so after 10 it will give us some kind of event. That event can be a negative edge or positive edge, some changes in output after a specific time, sorry, after a specific count, it is a counter. Or after a specific time, if it makes some changes, then it is a timer. Basically, the hardware required for designing a timer or counter is the same. Okay. Now come to the topic 8253 and 54. These both are the same thing. Even 8253 is the older version and 8254 is a newer version. 8254 is somehow better than 8253 in terms of, let's say, there are some differences. This is 8254. This is my 8253. So 8254 can work maximum up to 10 megahertz, while 8253 was the older version. So it was the maximum speed of 8253 was 2.6 megahertz only. So it can be observed that 8254 is faster. Okay. Second difference was 8254 is work on HMOS. HMOS is hybrid or high speed MOSFET, while 8253 was using NMOS. NMOS is N-channel MOSFET and it was a slow technology. So HMOS, because of HMOS, it was achieving 10 megahertz. Okay. And third difference is at the same time, like I say, 8253 and 8254 are the same thing, both having a 16-bit counters. The size of the counter or timer is of 16-bit, and both have the three different counters. It means 8253 can have three different counter of 16 bits, and 8254 also can have a three counter. But in 8254 we can read or write in one counter at same time. This was my first difference, this is my second, this is third, that we can read or write in one counter at same time. While in 8253 we cannot do this, because we cannot read or write in one counter at the same time. If any instance of time, either we can read or write. So either read or write in one counter at same time. One advanced feature with 825354 is it can support read back command. What is read back command, that I will explain, but it can support that read back command, while 8253 cannot support read back command. Okay, so these are the basic differences between 8253 and 8254. If in your exam they ask 8253 or 8254, the remaining things are the same, which I am going to explain later. All the things will remain same. So these are the basic differences. Now come to the block diagram or pin diagram of either 8254 or 8253. Both have the same type of block and pin diagrams, and both have the same type of features. So first discuss the features of 8254. Okay. So 8254 is having total 24 pins. Okay. It is TTL compatible. Okay. and it is supporting HMOS technology. Second difference is, second feature is 8254 features. What we are features. 8254 has 3 counter or timer of 16-bit each. A 16-bit counter means it can count up to 2 to the power 16. Means 0 to 2 to the power 16. A minimum count, and this is the maximum count possible. 2 to the power 16 is 536. So it can count up to this number. Okay, so this is the meaning of this 16-bit counter. And how many counters are there? 3 counters are there. Third feature is it can count in binary and BCD both. It can count in binary and BCD both. So if user want to count the numbers in BCD, binary coded decimal, then it can set some control register, a flag for BCD, or it can set for the binary. That will explain how we can configure BCD and binary counting. Okay, so these are some basic features. Some remaining features are similar, that it requires 5 volt supply, it is TTL compatible. Okay, it is compatible with the Intel ICs and all. Okay, so these are the basic features of 8253 or 54. Like I said, 8253 and 8254 are same. Okay, now come to the pin diagram. So this is my basic pin diagram of 8254. This is my 8254. Here we have a data signal D0 to D7. These are the data signal coming from 8086 processor. Then we have 2 control signal also coming from 8086, A0 and A1. We have a signal write or read. These 2 are also coming from 8086. It means all these data signals, A0, A1, write, read, all are coming from 8086. These are the things these are the signals by which 8086 control my 8254. I have another signal which is chip select. It is just for enabling or disabling this 8254. If chip select is 0, this is enable. If it is 1, then this is disable. Okay. As there are 3 different counters, in one counter, there are 3 signals required. First is 2 inputs for controlling the counter, that is CLK0 for counter 0, get 0 for counter 0, and out 0 is the output of counter 1. Like similar, CLK1, get 1, and out 1. Out 1 is output. Yes, it is correct. The clock and gate are the input signal. This is for counter 1, and as we have 3 counter, then this is the CLK2, gate 2, and out 2. This is the signal for third counters. So there are 24 pins. 2 pins are VCC and ground. Okay, these are the 2 different remaining pins. So we can count all the pins. 8 plus 9, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so there are 22, and okay, these are the 24. So 8 plus 9, 15, 16, 17 plus 5 is 22. Remaining 2 are left unconnected. We will not use those remaining pins. Okay, so these are the basic pins. Okay, 22 pins. These are the data signals. Okay, if in an exam they ask for the timing pin diagrams, So these are the data signal coming from the 8086. By using this data signal 8086, set the values in 8254, set the control commands in the 8254, set the count value in the 8254 using this D0 to D7 lines. If 8086 is writing something, it will send write 0 and read 1. If 8086 is reading count value, like if 8086 is reading value is going out of the 8254 toward the 8086, then read signal will be 0 and write signal will be 1. If 8086 is configuring or setting or sending some value or count values or some control, then it will set write signal 0 and read signal 1. Okay, and this CLK2, CLK1 and CLK0 are the clock signals. Clock signal are required, is a compulsory element for the counter or timer, because of clock we perform the counting. Like this is my clock signal. The clock signal is there for providing the events. Like each rising edge is an event. Each rising edge is an event. After each rising edge, okay, there will be a one event. So if I say that I want to set a counter of 100, so what is that 100? 100 is nothing but the 100 events. So 100 events of this clock 0. So after 100 events of this clock, something will happen. If I set my counter as on 100, if I set my timer of 50, and this clock, between the two interval there is a time delay of, let's say, 2 milliseconds. So after 50 it will be 2 into 50, it will be 100 milliseconds. So if I want to provide a time delay of 100 milliseconds, then I will set a count value of 50. So then 50 into 2 will be 100. If I want to provide a delay of 200 milliseconds, then I will set a count value of 100, because this interval is of 2 milliseconds. This is just an example. This interval can be changed. That depends on the clock. If I provide a clock signal of 5 milliseconds, and in this case I want a delay, time delay of 100 milliseconds, then I will set a counter of 20. 20 into 5 will be 100. Okay, so this something like this. If count, we want a count, then we will count this event. If we want a delay, then we will count that event, count the events with the cycle time or time period. Okay, so, and last in this timing diagram, these are the outputs. Outputs are there for setting the events. Output is something that after some count there will be some event, and this output is depend on the mode of the 8254. There are 6 different modes that we will explain later, but output is something which change after a fixed clock count. Okay, and gate is the something like starting. If we send a gate signal, then this counting or timing will get started. Without a gate signal, nothing will start. Okay, so if we want to count something, then we first need to press a button of gate. Okay, so if we send a gate signal, then counting or timing will start. Okay, so gate is for the starting, clock is providing the time delay interval, okay, or count events, and output is a something which change after that specific count. And these are the data signals. Now discuss this A0 and A1. These are the important elements. I believe I have explained all the signals except this A0 and A1. So for A0 and A1, there is a small table. This is, let's say, 80, A1. If both are the 0, 0, 8086 is sending this A0 and A1 to the 8254. Then if 8086 send A0 and A1 as 0, 0, then counter 0 selected. If it is 0 1, then counter 1 selected. If it is 1 0, then counter 2 selected. And if it is 1 1, then control register selected. Okay, for setting a selection of control register, then A0 and A1 must be set as a 1 1. Okay, in next lecture I will extend the control register and block diagram of 8051.